Okay, so if you rely on electricity day to day, and let's be honest, who doesn't? Then having a backup power source isn't just nice, it's becoming essential.
Absolutely. Grid
Yeah.
failures, outdoor adventures,
Mhm.
even just, tailgating. Reliable power matters.
Right. And when you start looking, you hit this big fork in the road almost immediately. Do you go with a traditional generator, the old reliable workhorse, or do you opt for the newer, maybe quieter inverter generator?
It's a fundamental choice.
That's exactly what we're diving into today. We want to cut through all the marketing noise, the confusing specs, and really get down to the core differences in design, how they actually perform, and crucially, which one is the right fit for you.
Yeah, and it's more than just looking at the wattage output now. That used to be the main thing.
Mm-hmm.
But today, it's really about how that power is delivered. Is it clean? Is it stable? Because what you're planning to run on it, especially modern electronics, well, that dictates everything. Using the wrong type can be a real costly mistake.
Okay, let's start right there. Let's unpack the basic mechanics. Under the hood, what's the fundamental difference in how these two types actually make electricity?
Well, the traditional generator is refreshingly simple, really.
Yeah.
You've got a fuel engine gas, usually, and it directly spins an alternator.
Right, like in a car.
Exactly. Simple mechanical energy gets turned into AC electrical power through electromagnetic induction. Pretty standard stuff.
And the key thing we found, the defining feature, seems to be the engine speed on those traditional models.
That's spot on. They're designed to run at one speed and one speed only. It's typically a constant high speed, usually around 600 RPM.
Always 600 RPM, no matter if you're powering a single light bulb or, a power saw.
Precisely. All or nothing. That constant speed is necessary to keep the AC frequency stable at, 60 hertz, which is what appliances expect.
Yeah.
But yeah, if the load is light, it's still roaring away, burning fuel like crazy. Not very efficient in those low load scenarios.
Okay, so that inefficiency leads us to the inverter generator. If the traditional way is simple, this one feels, well, a bit more complex. Why the extra steps? If the engine makes AC power anyway, why convert it to DC and then back to AC again? Seems roundabout.
It does seem counterintuitive at first, doesn't it?
Yeah.
But that complexity, that three-step process you mentioned, engine makes AC, a rectifier converts it to DC, then an inverter module converts it back to very clean AC. That's the magic trick.
Magic trick. How so?
It's not just about making power. It's about refining it, cleaning it up.
Ah, okay. So the first conversion to DC acts like a filter, smoothing things out.
Exactly. It takes the somewhat rough AC directly from the engine and turns it into stable DC power. Then that inverter module, which is basically sophisticated electronics, rebuilds a perfect AC waveform from that DC source. Pure sine wave, very stable.
And the big advantage there, aside from clean power, which we'll get to, is engine speed.
That's the other huge benefit.
Yeah.
Because the final AC output is created electronically by the inverter, it's decoupled from the engine's raw speed.
Yeah.
So the engine can slow down
Ah, so it adjusts.
dynamically. If you're just charging a phone, the engine might just idle. If you plug in something bigger, it ramps up. It only runs as hard as it needs to. That optimizes, well, pretty much everything: fuel, noise, engine life.
Okay, so that multi-step process, the AC-DC-AC dance, that directly leads to maybe the biggest practical difference for users today. The actual quality of the electricity.
Yes. This is critical. We need to talk about something called total harmonic distortion, or THD.
Right, THD. It sounds technical, but it's basically a measure of how clean or smooth the electrical wave is.
That's a great way to put it. Think of it like ripples on water. Perfectly smooth is a deal. Traditional generators, because the power comes straight from the mechanically driven alternator running at a fixed speed, tend to produce power with lots of ripples, lots of distortion, high THD.
And what does high THD mean in real terms? Why should someone worry about, say, 15% or even 25% in THD, which we saw some traditional models can hit?
It's like trying to run sensitive equipment on shaky ground. That electrical turbulence, voltage spikes, frequency fluctuations can really mess with modern electronics. Laptops, smartphones, smart TVs, microwaves with digital controls, even modern refrigerators.
So it could actually damage them.
Absolutely. It can cause malfunctions, shorten their lifespan, or just fry them completely. And think about medical equipment. CPAP machines, oxygen concentrators, running those on dirty power is a serious risk.
Okay, so the inverter's cleanup process directly addresses this THD issue.
Exactly. That final conversion stage creates a very smooth, stable AC waveform. We're talking THD typically under 5%, often even under 3%. That's very close to the power you get from your wall outlet. Utility grade power.
So, say for basically anything you'd plug into the wall at home?
Pretty much, yes. That's why they're considered essential if you plan on running sensitive electronics. It's just much, much safer for your gear.
All right, so power quality is a huge difference. What about noise? This seems almost as significant, especially for certain uses.
Oh, it's massive.
Yeah.
And it ties directly back to that constant engine speed we talked about with traditional models.
Right, running at 3,600 RPM all the time.
Oh,
That can't be quiet.
it's definitely not. Think lawnmower loud, or maybe a small motorcycle idling right next to you. We often see noise levels cited between 70, even up to 90 decibels for traditional open-frame generators.
Oof. Yeah, anyone who's been camping near someone with an old school generator knows that sound. It carries.
It really does. And that's precisely why inverters have become so popular for camping, RVing, tailgating, even just backup power in a neighborhood.
Because they can throttle down.
Exactly. When the load is light, the engine slows right down. Plus, they're usually built inside sound dampening enclosures. So the difference is dramatic. We're talking noise levels often in the 50 to 60 decibel range,
Which is more like.
like a normal conversation level. You can stand next to one and talk without shouting. It makes a huge difference to usability, especially if you're near other people or just want some peace and quiet yourself.
Okay, quieter, cleaner power. Let's talk practicalities. Fuel efficiency seems like an obvious win for the inverter, given the variable speed.
No question. Especially under light or moderate loads, which is actually most of the time for many users,
Yeah.
the inverter is significantly more fuel efficient. It's only sipping fuel when demand is low.
Whereas the traditional one is just chugging gas constantly.
Right. Burning fuel at near maximum rate, whether it needs to or not. Many inverters also have an eco mode or economy throttle that optimizes this even further.
I did notice, though, some big traditional units have enormous fuel tanks, so they might run longer on a single fill-up, even if they're less efficient.
That can be true, yes. A bigger tank equals longer runtime, obviously, but that doesn't change the efficiency, how much power you get per gallon of fuel. Gallon for gallon, the inverter generally gives you more operating hours, especially if your load varies.
And this efficiency and maybe the more complex engine design also seems to impact size and weight.
Definitely. Inverters tend to be much more compact and lighter. They often look like suitcases, some small enough to carry with one hand, maybe 30, 40, 50 pounds.
Designed for portability.
Exactly. Traditional generators, with their larger engines and simpler open frame construction, are usually much bulkier and heavier. You often need wheels, maybe two people to move them, not something you casually toss in the car.
Okay, so inverter wins on clean power, quietness, efficiency, portability. This feels like a landslide, but there has to be a catch. Let's talk about the elephant in the room. Cost.
Ah, yes, the price tag. This is where the traditional generator fights back, and it's a significant factor.
How significant are we talking? If we look at, say, a generator around the 5,000 watt mark, what's the typical price difference?
It's huge. You might find a solid, reliable 5,000 watt traditional generator for, let's say, under $1,000. Maybe $700, $900.
Okay, reasonable for that much power. And the inverter equivalent.
You're easily looking 3, maybe 4 times that, often around $4,000, sometimes more, for a comparable wattage inverter model.
Wow. Okay, that's a major difference. Why is it so much more expensive?
You're paying for the technology inside. The sophisticated inverter module, the rectifier, the sensors, the electronics that manage the variable engine speed, plus the sound dampening enclosure. It's just a more complex, precisely engineered machine.
So there's a long-term value argument, I suppose. The fuel savings might eventually pay off that higher initial cost.
That's the idea, especially for people who use their generator frequently. RVers who run it often, campers, maybe someone who experiences frequent long power outages. The fuel savings can really add up over hundreds of hours of use.
How quickly could someone, say, break even if they use it maybe 50 or 100 hours a year? Is it years? Decades?
It really depends on the price of fuel and the specific models, of course. But yeah, for frequent users, reaching that break-even point within, say, 3 to 5 years isn't unrealistic, especially considering how much fuel a traditional generator wastes under light load. That lower operating cost is a real factor over time.
Interesting. Now, you mentioned portability earlier and how the compact design of inverters is an advantage there. But you also hinted it might be a downside for maintenance.
Right. It's kind of a double-edged sword. Traditional generators, being open frame, are generally very easy to work on. Accessing the engine, the spark plug, the carburetor, the air filter, it's all right there.
Simple mechanics, easy access.
Exactly. Inverters, packed tightly into their quiet enclosures.
Mm.
Well, getting to those same components can be trickier. And if something goes wrong with the actual inverter electronics, that specialized stuff, repairing that can be more complex, potentially more expensive than fixing a simple mechanical issue on a traditional unit.
So simpler maintenance on the traditional side. Got it. Before we kind of tie this all together with who should buy what, any other key features worth mentioning? Parallel capability seems like a big one for inverters.
Yes, that's a great point. Many inverter generators, especially smaller ones, can be linked together with special cables. So you could buy two smaller, lighter 2,000-watt units, for instance, and run them in parallel to get 4,000 watts when you need it.
Gives you flexibility. Use one for light loads, two for heavier stuff.
Precisely. That's a feature you generally don't find on traditional models. Also, emissions. Because they manage combustion more precisely with variable speed, inverters tend to produce lower emissions, making them a bit more environmentally friendly.
Okay, so bringing it all home. Cleaner power, quieter, more efficient, more portable, parallel capable, but significantly more expensive and maybe trickier to service for the inverter. Raw power, louder, less efficient, heavier, simpler to service, and much cheaper for the traditional.
That sums it up pretty well. The choice really boils down to your specific needs and priorities.
Let's make it concrete. If I'm a listener thinking, okay, I just need basic home backup for emergencies, maybe powering the fridge, freezer, a few lights, maybe the furnace fan, the cheap traditional generator seems tempting. Is that high THD power really going to hurt my modern fridge?
That's the million-dollar question, isn't it?
Hmm.
For older, purely mechanical appliances, maybe not. A simple heating element, an old-style motor, they might tolerate it. But most modern refrigerators have electronic control boards. Furnace fans often do too. Sump pumps. Even basic things are getting smarter.
So even for basic backup, there's a risk.
There is a risk. Maybe it'll be fine, maybe it won't. But are you willing to gamble with a $2,000 fridge or a $5,000 HVAC system to save money on the generator? For some things, like, say, heavy-duty power tools on a construction site, the raw power is fine. They're built tough. But for a typical home, the risk to electronics is genuine.
So boil it down for us. When should someone definitely choose an inverter?
Okay, choose an inverter if you need to power sensitive electronics, computers, TVs, smartphones, modern appliances, medical devices. If quiet operation is critical camping, RV parks, neighborhoods with noise rules, tailgating. If you value portability and fuel efficiency. They're ideal for recreational use in most light to medium home backup scenarios where protecting electronics is key.
And the traditional generator still has its place when?
Stick with traditional if you're running truly heavy-duty, non-sensitive loads, big construction tools, large motors, welders, if noise isn't a major concern. And critically, if upfront cost is the absolute primary driver and you understand or can mitigate the risks of higher THD power for whatever you plan to run, it still offers the most raw wattage per dollar spent.
Okay, so the reliable workhorse versus the modern refined solution. It's quantity versus quality, noise versus quiet, cost versus features.
A pretty clear trade-off once you understand the core differences.
We've covered a lot: the engine tech, the power quality, noise, cost. Hopefully everyone listening now has a much clearer picture of why these two types are so different and which might suit them best.
And just before we finish, a really important safety note. It applies to both types. These are combustion engines. They produce carbon monoxide.
Lethal, invisible gas.
Exactly. Never, ever run a generator indoors or in a garage or near windows or vents where the exhaust can seep inside. Always outdoors, well away from the house. Some newer models have automatic CO shutoff sensors, which is a great safety feature.
But not a substitute for proper placement.
Absolutely not. Safe operation is paramount, regardless of type.
Okay. So a final thought to leave people with.
Yeah, something to chew on. Given how deeply integrated sensitive electronics are becoming in everything in our homes, not just computers, but fridges, ovens, thermostats, even lighting systems, is relying on high THD, dirty power from a traditional generator truly a sustainable backup strategy for the average modern homeowner anymore, even if it saves you money up front.
Is the potential cost of replacing damaged electronics worth the initial savings on the generator itself?
Exactly. It's a question of risk assessment for your specific situation, something to really mull over as you decide on your power needs. Choose wisely.
That is definitely food for thought. Fantastic insights. Thanks for breaking it all down. And thanks to all of you for joining us on this deep dive. We'll catch you next time.